Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. In today's video, we are solving this probability in Stats 2 paper, popularly known as S2. And this is of May-June 2024, variant 63. So let's get started. The time is 9:38 and we will solve the whole paper. So 9:38 p.m., that is the start. And let's see how much time will it take. I think maximum of 1 hour. Now the question says, the random variable x has the distribution. X follows a binomial distribution 4000, 0.001. Use a suitable approximating distribution. Find the probability x lies between such and such. Now 2 is inclusive, 5 is not. So in other words, probability x lies between 2 and 4 inclusive. Now, since they want us to use a suitable approximation, I'll write n as 4000, p as 0.001. Therefore, when I evaluate np, that comes out to be 4. They are also asked for justification. So let me write justification over here. N is greater than or equal to 50 and np is less than 5. Therefore, x now follows a Poisson distribution with lambda. And what is lambda? That is np, because we know that expectation of x is np, that's the same thing as lambda. So now over here, let me reduce the brightness a bit. So I'll write x follows a Poisson distribution with 4. And this is simple calculation. Probability x lying between 2 and 4. So therefore, e raised to power of -4. 4 raised to power of 2 over 2 factorial, 4 raised to power of 3 over 3 factorial, 4 raised to power of 4 over 4 factorial. Simple basic calculation. This answer is 0.537, correct to 3 significant figures. So maybe at the end, add 10 minutes for calculator usage, because I have already done the calculation. And I'm simply writing down the answer after showing you all the steps. So at the end, add 10 minutes. Question number 2. It says the widths of a random sample of 150 leaves of a certain kind were measured. The sample mean was found to be 3.12. So W bar, that is 3.12. Use the sample. Using this sample, an approximate 95% confidence interval for the population mean of widths in this centimeter was found and such and such. So this is confidence interval for population mean. And this is symmetric confidence interval for population mean. So now, first of all, 3.01, that's the lower bound. 3.23, that is the upper bound. So therefore, the difference is 0.22, that is the width of confidence interval. So also it's a 95% symmetric confidence interval. So therefore, what should I do? Grab a normal distribution thing, which is somewhere over here. There it is. And right over here, 95% in the middle. That is 95%. 2.5% at this corner, 2.5% at this corner. Read the z value for 97.5%, a very famous value. So z value is 1.96. So z value is 1.96. And that's the width. And n comes out to be 150. So let's use the width formula. So the width of confidence interval is 2z sigma over root n. So therefore, 0.22 equals to this value, which is 2 times 1.96 times sigma times divided by root of 150. Simplify, and you get the value of sigma as 0.687, correct to 3 significant figures. So that's how this particular question is done, the first part. The second part, it says another reasoning part. Explain whether it was necessary to use CLT in your answer to part A. In your answer to part A, we use the z value. That means we are assuming that it's following a normal distribution. Is it really following a normal distribution? Have they explicitly mentioned it? No. So since it was not explicitly stated that distribution is normally distributed. Therefore, yes, it's necessary to apply CLT. And what is CLT? The sample size is large. What is the definition of sample size? Large. That is, n is greater than or equal to 30. Therefore, it becomes approximately normal distribution. That is what CLT is all about. So yes, it's necessary that CLT has to be applied. Question number 3. Now it says the masses. Let me just get a highlighter over here and a red highlighter and a black pen. So now it says the masses in kilograms of large and small bags of cement have the independent distribution such and such. So let me erase this thing. This is red and this is red and this is blue and this is blue. So let me write over here. This is blue. This is red over here. This is for large and this is for small. So large follows a normal distribution 50, 2.4. 2.4 is the variance. Small follows a normal distribution 26, 1.8. Now it says find the probability total mass of 5 randomly chosen large bags. So there are 5 large bags of cement is greater than total mass of 10 randomly chosen small bags. And this thing is about greater. So we'll put that thing later on. So I'll write X as L1 all the way till L5. That is large. And instead of S, I'm writing Y. That is S1, S2 all the way till S10. So what is expectation of X? That is 10 times 50. What is variance of X? That is 10 times 2.4. What is expectation of Y? That is 10 times 26. What is variance of Y? That is 10 times 1.8. Now let me introduce another variable. Lx is greater than Y. 5 large is greater than 10 small. So X is greater than Y. X minus Y is greater than 0. Let me write W is equals to X minus Y. So now expectation of W, that is expectation of X minus expectation of Y, and variance of W, that is variance of X plus variance of Y. So therefore, this is 10 into 2.4, 10 into 50, that is 500 minus 260, that comes out to be 240. So that is one thing that we get. And then what else do we have? We have, that is 5, my bad. That is 5, that is 5. And let me just correct myself. So this is 5 large bags, that's 5. This is 5 into 2.4, 5 into 50, it's 250 minus 260. That comes out to be negative 10. And variance is added. 5 into 2.4 plus 10 into 1.8, 5 into 2.4 plus 10 into 1.8, that is 18. And that is how much? 12. That comes out to be 30. So now W still follows a normal distribution, negative 10, 30. This thing is done. Now we want to calculate this thing, the purple thing, that is W, and W is greater than 0. That is W over here. So probability W is greater than 0. Probability Z is greater than 0 minus 10 divided by square root of 30. Let's use the calculator. Probability Z is greater than positive 1.826. Rule number 2, 1 minus probability Z is lesser than 1.826. Go to the table, the Z table, and use the Z value to find the corresponding probability value. And then this is 1 minus this particular value. I have the value after subtraction, 0.0339. That's the answer, correct to 3 significant figures. So that's a linear combination question. Question number 4. In this question, you should not use an approximating distribution. Okay, we will follow the rule. At an election, this town, Menhem, last year, 24% of the voters supported the Today party. A student wishes to test whether the support for this party has decreased since last year. He chooses a random sample of 25 voters, finds that exactly 2 of them say that they support the Tea party. Calculate, 5% significance level, test at the 5% significance level, whether the support has decreased. Now, what is the question all about? It's about binomial. So what do? It says X follows a binomial distribution. A sample of 25 is taken. Probability of success is 0.24. H naught P is equals to 0.24. H1 decrease P is less than 0.24. And the sample value that we found, that is exactly 2. That is 2 by default. This is inclusive. And what else is there? We have this thing that is the 5% significance level. Now, what do? We'll calculate the probability in the lower tail direction. X is less than or equal to 2 according to the binomial formula. That is 25C0 and then 2 brackets, and then 25C1 and then 2 brackets, and 25C2 and then 2 brackets. Now, let me adjust the height of this thing, my stand. And I think that is good enough. So therefore, the probability of success is this thing, which is 0.24. So this is 0.24, this is 0.24, this is 0.24, power is 0, 1, and 2. And probability of failure, 0.76, 0.76, 0.76, power is 25, power is 24, power is 23. Now plug all this thing in the calculator. And then write down the answer. This answer is coming out to be 0.0407, correct to 3 significant figures. Now convert it into percentage, 4.07%. Now, what is the rule? The rule is if the p-value is lesser than significance level for a one-tail test, if this is the rule, then reject H naught and accept H1 and so on. So now 4.07%, is it lesser than 5%? The answer is yes. Therefore, reject H naught, accept H1, and now come the golden words that you have to write in order to gain mark from the examiner. So therefore, I'll write, there is sufficient evidence at 5% significance level to accept that what you call, that is the Tea party, and that is the popularity. Support has decreased. To accept that support for Tea party has in fact decreased. So that is what you have to write. Okay, so that will earn you your marks. So 4 questions are down. Now let's look at question number 5. What is question number 5 all about? Question number 5 is about the concept of CRV. So it says it's an algebraic thing. I don't think so any ln or something is applicable over here. Sometimes that is. A is a constant. We have to find the value of A. So first of all, integrate the function. That is ax minus x cubed dx between the limit 0 and square root of 2. And it should equal to 1. First of all, integrate each term. That is ax square over 2 minus x power 4 over 4 between the limit 0 and root 2. And this equals to 1. So first of all, root 2 square becomes 2. And root 2 square into root 2 square, that is 4, because this is root 2 power 4. So I have A, I have root 2 square. Hold for a second. Let me just remove this bracket. And this is root 2 square divided by 2 minus root 2 power 4 over 4. That is the upper limit minus the lower limit is 0 and 0. This equals to 1. So this is A, this is 2, this is 2, this is 4, and this is 4. and minus 0 equals to 1. So a minus 1 equals to 1. That was simple. A comes out to be 2. Find the median of x. So now lower limit is 0, upper limit is m, and this is ax minus x cube. That is 2x minus x cube between the limits 0 and m equals 2.5. Because median 50% lies below median. 2x squared over 2 minus x4 over 4 between the limits 0 and m equals 2.5. So therefore, this 2 cancels out. That is m squared minus m power 4 over 4 minus 0 equals to half. Multiply throughout by 4. 4m squared minus m4 is equals to 2. Therefore, let me write over here, m4 minus 4m squared plus 2 equals to 0. So now let's see if this is factorizable. I don't think so. So therefore, let me write over here the coefficient. Let me first make a substitution. Let y is m squared. Therefore, y squared is m power 4. So this is y squared minus 4y plus 2 equals to 0. Coefficient of the square term is 1. The y term or the x term is negative 4. The constant term is 2. Let me evaluate v square minus 4ac first. That is negative 4 whole square minus 4 into 1 into 2, 4. This is 16 minus 8. That comes out to be 8. And square root of 8 is square root of 4 into 2. That is 2 root 2. So I can use this. So let me draw a small line in the middle and let me work on this side. So therefore, we are solving for y. So y is equals to minus b, minus or minus b, that is plus 4 plus minus 2 root 2 divided by 2. That is 2 plus root 2, that is y, but y is equals to m squared. So therefore, this is plus and a minus. So therefore, m squared is equals to 2 plus root 2. M squared is equals to 2 minus root 2. This is 3.4142, and this is 2 minus root 2. This is 2 minus, let me write over here. This is 2 minus 1.41, hold for a second, 4142. This comes out to be 58.5858. Now, when I take the square root over here, this comes out to be 0.765. M is 0.765. This is m squared. This is m squared. So now 3.4142. This is coming out to be, hold for a second, the square root. That is 1.847. So m is 1.847. Now remember, m or x, that value lies between 0 and root 2. So therefore, discard. This is out of reach. Therefore, accept. This is within the range. So this is within the range. So therefore, the answer of m is 0.783. Something like this. So just check the working. I think I did not use the calculator properly. So this is 2 minus root 2 and 2 plus root 2. So 765. I think that's the answer. So let's move on. If there is any small decimal mistake, just take care of it. Now over here, expectation of x. So first of all, let me just remove this. How do you calculate expectation of x? That is between the limits, full limits, 0 till root 2. This is x into 2x minus x cubed dx. Let me double check. This is 2x minus x cubed. Perfect. First multiply, then integrate. That is 0. That is root 2. That is 2x squared minus x power 4 dx. And now integrate. That is 0. No, we are integrating. So remove this integral sign. That is 2x cubed over 3 minus x power 5 over 5 between the limits 0 and root 2. So now this is 2/3 and this is root 2 cubed minus root 2 power 5 over 5. Minus 0, minus 0. That's a good thing. And I think it's about time that we use, does it ask for the exact value? Yes, it's asking. So now, first of all, that's where you have to apply all your knowledge. Root 2, root 2, root 2, it's 2 root 2. And root 2 raised to power of 5. Hold for a second. These two is 2, these two is 2, and this is root 2. So that's 4 root 2. So first of all, this is 2 over 3, and this is 2 root 2. And this is 4 root 2 over 5. All good? So now this is 4 over 3 root 2. This is 4/5 root 2. Let me write this 4 root 2 outside. This is 1/3 minus 1/5. So therefore, this is 15. This is 5 minus 3 into 4 root 2. 2 into 4, that's 8 root 2 over 15. That's the answer in the exact form. So even in S2, they are making us work with the exact form and this guy's quadratic equation. That's too much of pure math. Now let's look at this. Question number 6. What does it say? The number of green sweets in 200 randomly chosen packets of Fructose are summarized. Number of green sweets and number of packets. This is a distribution table, a frequency distribution table. So let me write over here. This is frequency distribution. They have asked after a long time. Calculate unbiased estimate. They do ask unbiased estimate all the time for population mean and show that the unbiased estimate of population variance is this much. That is not the issue. The issue is this thing, that what they have asked, that is this thing. So this thing over here. And what do we need? We need few things from S1. First of all, X bar, that is sigma Fx over sigma F. That's one thing. And we know that sample variance, that is sigma Fx square over sigma F minus X bar square. And then unbiased estimate of population mean, it's the same thing as sample mean. Unbiased estimate of population variance, it's n over n minus 1 sample variance. So these two are for the sample. So this is for sample that you have studied in S1, and this is for population, and this is unbiased estimates. Got the idea? So now I think it's a good idea that we make table, because there are only 4 values. So we can either use the table or without the table. That's your choice. So let me make a table over here. And I think 5 columns are there. So first column is for X, this is for F, this is for X squared, this is for Fx, this is for Fx squared. So this is 0, this is 1, this is 2 and 3. So this is 2 and this is 3. A greater than 3 is not needed because the frequency is 0. So that is 32, that is 50, that is 97, that is 21. X squared, 0, 1, 4, and 9. Now, let me focus on this. You take X, you take X, you take F, you multiply, you get Fx. You take F, you take X square, you multiply, you get Fx. So that's the thing that you need to do. So this is 0, X into F. That is 0. This is 50, 97 into 2, 180 plus 14, 194. And 21 into 3, that is 63. Add it all up, that is sigma Fx. Add it all up, that is sigma F, which is already given us 200. Add it all up, this will be sigma Fx square. So let me get this thing right. So this is still 0. And this is still 50. 4 into 194. 4 into 194, that comes out to be 776. And 63 into 9. 63 into 9, that comes out to be 567. So now sigma Fx, this is coming out to be, I think, 307. You can double check my working. Sigma Fx square is coming out to be 627. So therefore, X bar is sigma X over N. This is unbiased estimate. This is 307 over 200, which comes out to be 1.535. 1.535, this is exact. And unbiased estimate of population variance, it's N over N minus 1 sample variance. This is sigma Fx. This is not sigma X because this is not raw data. This is frequency distribution. Let me write it properly. So this is sigma Fx over sigma F. Got it? This is sigma Fx squared, which is how much? Which is 627 over 200 minus 307 over 200 square. Use a calculator, and this comes out to be 0.783. So that is the answer for this particular thing. Now the real part starts. Now it says the manufacturer of Fructose claim that the mean number of green sweets in a packet is 1.65. That's the mean. NG believes that the true value is less than 1.65. She uses the result from 200 randomly chosen packets to test the manufacturer's claim, state suitable, null, and alternative hypothesis. That's 1 mark. Show that the result of Anji's result is significant at 5%, but not at 1% level. And first, let's do this. So 4 plus 1 is 5 marks. X bar follows a normal distribution. So what is the mean that we are taking? We are taking the mean as 1.65. And the variance is this one, which is 0.783. This is 0.783. If it's not exact, use the unrounded value. And this is 200. So I'm basically mixing part B and C together. And over here, I'll write H naught. Mu is 1.65. H1 mu is less than 1.65. And now let me calculate Z. Z is 1. How much is the value? The sample value is 1.535. So sample value is 1.535. Okay. So yeah. So this is 1.535 minus 1.65 divided by 0.783 over 200. 0.783 divided by 200 square root. Now this value is coming out to be negative 1.838. Let me grab this thing, the normal distribution curve, 2 of them. So that's the first one. That is the second one. First of all, let me focus on lower tail 5% significance level. So this is 5% significance level. This is negative 1.645. And this one is 1%. It's not drawn to scale, so don't worry about that. 1% significance level, negative 2.326. Now this is the Z calculated value, negative 1.838. So now this is where this is inside the critical region. So that's where the Z calculated value is. And over here, the Z calculated value is outside of the critical region. So when it says the result is significant, that means, what does that mean? Result is significant means H naught is rejected in favor of H1. So therefore, since Z calculated lies inside 5% critical region, result is significant. Since Z calculated value does not lie inside critical region, result is not significant. That is what they were asking. So instead of 1 significance level, they gave us 2. For one of them, the result is significant. For the other, it's not. It is given that NG made a type 1 error. Explain how this shows that the significance level that NG used in her test was not 1%. That means the significance level used was 5%. Now, type 1 is associated with reject H naught when H naught is true. So when do we reject H naught? When we are in the critical region. When are we in the critical region? When the result is significant. So what should you write for 1 mark? You should write that type 1 error is associated with critical region. The Z calculated value is in the critical region at which level? At the 5% significance level. So yes, the significance level was not 1%, it was in fact 5%. So that's how this thing is done. Now let's look at this question. Let me just come back in few seconds. Now I'm back. Let's get started with this. It says the independent random variable X and Y have the Poisson distribution such and such. So there is X and there is Y. So let me just use red for X. X is this thing so that I don't make a mistake. And Y is this. And then find the probability X plus Y is less than 4. So now it's talking about total. That is the first thing. Let W is X plus Y. So W still follows the Poisson distribution. The means are added 1.9 plus 2.2. How much is that? That is 4.1. So W follows a Poisson distribution with 4.1. Probability X plus Y is less than 4 means probability W is less than 4 means probability W is less than or equal to 3. So e raised to power of negative 4.1, 1 plus lambda square over 2 factorial lambda cube over 3 factorial. These are the terms that you would use. Put everything in the calculator. This comes out to be 0.414, correct to 3 significant figures. The clarity, look at the clarity of how I am working and making usage of the given space, which is perfectly fine. What is part B? Find the probability X is 2. Given that X plus Y is less than 4, this is answer of part 1. Keep that in mind. So first of all, it's a scenario of conditional probability from S1. And answer of part 1 is the condition. Condition goes down in the denominator. Something relevant out of the condition goes up. Now, when we are talking about X plus Y less than 4, that means X plus Y can add up to 3. X plus Y can add up to 2. X has to be 2. Keep that in mind. That means if I take this to be 2, this would be 1. Makes sense? And if I take this to be 2, then X should be 0. So we are working for this. So now let me write down the probability. Probability X is equals to 2. Only for X, that is Poisson distribution 1.9. So now let me write over here like this. First of all, X follows a Poisson distribution with 1.9. Probability X is equals to 2. E raised to power of minus 1.9. 1.9 square over 2 factorial. Whatever the answer is. X follows, now we are talking about Y. Y follows a Poisson distribution with 2.1, I think. 1.9 and 2.2. Not 2.1, this is 2.2. So now we are looking for probability Y is equals to 1. That is E raised to power of negative 2.2, 2.2 raised to power of 1 over 1 factorial. And similarly, probability Y is equals to 0. That is E raised to power of negative 2.2, 2.2 power 0 over 0 factorial. Now there are two scenarios. First of all, X is 2 and Y is 1. X is 2 and Y is 0. So first of all, there is or, there is and, there is and. Got the idea? So it's either or. First of all, calculate this probability, or means add it up. Calculate this probability, this probability. So this probability is already there. E raised to power of minus 1.9, 1.9 square over 2 factorial. The same thing over here. E raised to power of negative 1.9, 1.9 square over 2 factorial. And means multiply y is equals to 1, that is e raised to power of negative 2.2, 2.2 power 1 over 1 factorial, and e raised to power of negative 2.2, 2.2 power 0 over 0 factorial. So now this whole thing over here, let me draw a box around it. Just a simple line would do. This thing is your numerator. So this thing over here, that is your numerator. And what is the denominator? The denominator is answer of part 1, which is right over here, which is 0.414. That is 0.414, that goes down. So therefore, 0.0957 divided by 0.414, this comes out to be 0.231, correct to 3 significant figures. So yes, it was a large question, but very technical. Now, the very last part, what is it about? A sample of 60 randomly chosen pairs of values of x and y are taken. So let me highlight this thing. What are they talking about? They're talking about 60 randomly chosen pairs. Let me make it thinner. 60 randomly chosen pairs of values of x and y is taken. The value of x plus y is calculated for each pair. The sample mean is this thing. Find the probability. Sample mean is less than 4. So basically, we used this is related to part A. W follows a normal distribution, Poisson distribution, that is 4.1. So this is x plus y. Now we want to apply CLT. Why? Why are we applying CLT? Because the sample is large, n is greater than or equal to 30. Sample size is 60. So now W bar follows a normal distribution. 4.1 is the mean, 4.1 is the variance, divided by 60. We know that for Poisson distribution, expectation of x is lambda, so is variance of x. So therefore, probability W bar is less than 4.0. Probability Z is lesser than 4.0 minus 4.1 divided by 4.1 over 60 square root. That is the simple thing, a sampling question that we were supposed to do. So probability Z is lesser than negative 0.383. Just do double check my answer. And that is the same thing as Z greater than positive 0.383. Which is 1 minus 5 of 0.383. Go to the Z table, calculate the probability. Final answer is coming out to be 0.351. That is the answer. So that's how this particular question is done and dusted. And what time it is? This is 10:16. Now I said add 10 minutes for calculation thing. And we started at 9:38. It's 10:16. Add 10 minutes. So this is 22 minutes plus 16. So 22 plus 16 plus 10. That is 22 plus 26, which is what I finished it in 48 minutes. And that is too perfect. So that's how this particular paper is solved at Mathematics with Shahab Yaqub. Take care, everyone.